Welcome to day 2 of AWE. We have another fantastic presenter for you today. The man, the myth, the legend, Sascha Kiener from Svarmony. He is the founder in the industry for over 15 years. My name is Grace. I run a little company that's a location-based language learning app. So if you have any interest about that, talk to me afterwards. But right now I'm going to pass over the mic to Mr. Kiener while he talks about discovering the future of AR with his indoor navigation.
Thank you, Grace. So first of all, hello to everyone. Thank you for coming. In the next 20 minutes around, we will dive a little bit more into the topic of visual indoor navigation or visual positioning. And as being in AR for like more than a decade already, almost 15 years, it's so great to see at AWE how the whole conference grows, how the audience and the community is really getting bigger and the technology is getting better, and we see really like lots of nice use cases coming out every month basically. And today we talk a little bit about how the indoor navigation and especially visual indoor navigation will truly change the world we know, and how indoor positioning is a very important puzzle piece that will allow merging the analog world with the digital world completely, and it will immerse us in the future more to experience really nice digital experiences. So first of all, let's start with a little quote from John Hankey, the CEO of Niantic. In a recent interview, he said, "Being outside, socializing with other people, shopping, playing, having fun, AR can make all those things better." And he's totally right, in my opinion. More and more CEOs of large tech companies speak up about augmented reality and the huge amount of possibilities this technology can offer for us. Nevertheless, one of the biggest problems up to date is to accurately link digital content at the correct place in a space, especially indoors. And the bigger the buildings are, the more hard it gets to get an exact position indoors to locate yourself and to place content at the right place. So basically, there is existing technologies already that are being used, like 3D recognition, edge-based tracking, where you can track machinery, cars, and other objects, and spatial tracking for smaller spaces, but there's no real solution yet for real augmented reality in large spaces like this building, for example, like trade shows or like museums. And first, a little bit about us, a little more information about Svarmony, who we are. We are in the business for like more than 15 years already. We have a large variety of different industries that we work with. Especially the automotive industry is one of the biggest that we are working with at the moment. And we have a suite of products and solutions that we offer now to our customers. And one of these solutions is aryve, our new indoor navigation system that I will present to you today. The other solution we offer also, that you can also see at our booth later on, after the presentation, is our avatar solution. That is that can be an ideal brand representative or digital guide that basically explains you either an exhibition in a museum or guides you the way through a shopping center, for example, or helps explaining your product to your customers. Our visualizer solution, like the Bentley visualizer that you can download from the App Store, and the Porsche visualizer shows the car in 3D. You can configure the car, you can change the colors, and really see how it looks like in your driveway. Our mission is to transform the way people interact with physical and digital objects. And that's why our solutions can benefit customers all over the world by boosting their brand visibility, cementing the customer loyalty, and personalizing product experiences. In the world we live in, buildings are big. And if it's a shop, a mall, or an airport, the buildings we know and the buildings we go to are getting bigger and bigger every year. New buildings are built, the malls are getting bigger, airports are getting bigger, and it's harder and harder to navigate through these buildings. So I would like to ask you all to imagine that you're at a large airport that you don't know and you are trying to find your gate. Instead of looking at a really confusing map or a plan, basically, to find where you have to go, you could just use your phone, or in a few years in the future, maybe AR glasses that will guide you the way through the building and give you really useful information along the way. Or consider a trip to a massive shopping mall, for example, to understand, trying to understand those sometimes really confusing maps with this little "you are here" dot, and then you have to remember basically all the turns you're going to find your shop or where you want to go in the shopping mall. With our solution, you will just see an illuminated path, like a path of breadcrumbs you just have to follow, and it shows you the exact distance, it shows you turn-by-turn navigations, and it gives you more additional content like 2D content, 3D content, or videos on the way. So how does it currently look like? This is a typical building map from a school, for example. You see this little small "you are here" dot in the middle, and now imagine you have to go to number, let's say, 26 up there, all the way up there. You have to remember the whole way, and then you leave the map that's printed somewhere on the wall, and you have to navigate through and then maybe ask people on the way. So it can get really confusing, especially in a building of this size. And there's also more interactive indoor navigation, which uses your position combined with a map, and it calculates a route for you to walk on, like on Google Maps. So you're looking at the map, you get a more or less accurate position of where you are, and it gives you navigation to the point where you are. The problem with this is you need to have a technology that gives you an exact position inside the building. And there's not that many technologies at the moment available that can really deliver this. So what are the technical reasons for vision-based navigation, and what's basically the technology behind, or the technologies that are available at the moment on the market? Number one would be GPS. GPS everybody knows, everybody uses in the car, outside when you want to find a shop. Indoors, it just doesn't work at all. It's like you have no precision. It doesn't go through building walls or through building ceilings, and the positioning is really bad, or it doesn't work at all. Other wireless technologies like Bluetooth triangulation, Wi-Fi triangulation, basically all RF technologies, even 5G, they allow through triangulation a more or less accurate position. But the problem is, the higher the frequency of the signal is, the less it goes through walls, through bodies, through other objects. So basically, when you use Bluetooth navigation and you're standing in front of a Bluetooth beacon, for example, you turn around with your back to the beacon, your position will change due to the water in your body. 5G positioning is supposedly a little bit more accurate, but it's not implemented yet, and it also works only on maps. So it doesn't work with AR, so you cannot place content on the floor or anywhere. There are, of course, some other technologies like ultrasound, light frequency, you might have heard of, that basically uses the frequency of the lights on the ceiling and the phone's camera to detect under which light you're standing at the moment. But for this, you have to install expensive hardware, and you have to do many changes in the building. And there are, of course, some other technologies like Earth magnetic field. So you can use the compass of your phone, walk through the building, and basically the phone records the magnetic field it detects while you're walking through the building. Also, these technologies are not that precise, maybe up to a few feet, but not more. So with aryve indoor navigation, built by our amazing R&D team at Svarmony, we are sure we will lift indoor navigation in large spaces to the next level. And so what it is and why it is so groundbreaking, I will explain you now. So basically what we do with aryve is we combine accurate camera-based positioning with indoor navigation in AR, and it outsources the necessary computing power to a server that can either be inside the building or it can be in any cloud. And some of these functionalities that we can provide with aryve are, for example, dynamic routing for user guidance and ability to show interactive 3D content either at the fixed position or on the path of the user. So the following video shows a little bit briefly how aryve works technically. recently, we also have installed aryve at the Deutsches Museum in Munich, which is one of the biggest history museums in the world currently. And we installed it there to show how it can improve not only visitor guidance, but also add useful information while you're doing your walk through the buildings. And when you have special interests, you can choose your interests and basically get a tour based on your interests through the museum. So in this clip, you can see how easy it is to navigate indoors when you really can see where you want to go. So besides museums, there are also many more use cases for such kind of a navigation. There's, for example, as I said, there's shopping malls, there's retail stores, basically finding your product in the store. If it's a Home Depot store, if you want to find any kind of TV, you can just enter what you're looking for and you get directly where the TV is in the store. There's also airports, of course, that can be really confusing, and it helps visitors or it helps travelers to find their gate quicker, to find the lounges, to find the shops and everything else. There's also public buildings, there's offices, train stations, hospitals, art galleries, hotels, and even more places like universities, schools, and stadiums, where this kind of navigation can also be really useful. And at the moment, we are just starting with aryve. So for now, we focus on 3 main verticals, mainly the shopping malls, we focus on museums, and we focus on airports at the moment. Since these use cases are quite have a lot of similarities with each other, and this is why we are starting with those. So let's dive a little bit more into the technical part and how it works on a high level. So first, now, how do we get the buildings inside our system? We start creating a map. We use standard LiDAR scanners that basically everybody uses to do like virtual tours through buildings. At the moment, we use a Leica 360 scanner, but we can use any kind of LiDAR scanner that provides the standard RAW format for LiDAR scans. That's E57 files. So with one of these scans, what we need is the E57 file, and we need located 360-degree images from the scanner. The Leica scanner has a camera, Matterport has a camera. Most modern scanners use 360 cameras, so we can use this data. So what's the reason why we use it? Before, there were many solutions where you could use a mobile application. You walk through the room, you get a recording from the room, and then you get basically a 3D image of the room that you can use for localization. The problem with mobile phones is the bigger the building gets, the more drift you get, the more inaccurate the map gets, and then in the end the navigation is not accurate enough and you cannot merge it together with the 2D map of the building because it just doesn't fit. And one of these problematics is there's possibilities trying to solve these problematics. It's called loop closing. So basically you're walking through the building in a loop, and when you come back to the position where you started, the application should detect that you are there, and then it corrects the map accordingly so that the loop is being closed. But this also induces errors, especially when the building is really, really big. This is, for example, a scan result from our Leica scanner that we are using. And it shows our office in Vienna. And here you can see how the map looks like. So we basically get a colored map with almost like half transparent walls. And it's very easy to navigate through this map and to see where you are in the building. And this helps us when we want to add the content that we show that people will see when they use their phone inside the building. So then, what then happens is basically after the LiDAR scans are done, the user can upload the E57 file and the 2D floor plan to our backend via the CMS. And in one of the next releases, the 2D floor plan will be created automatically from the LiDAR map, but you can also always upload your own floor plan if you have one. But from our experience, many of our customers don't even have really good floor plans in digital version that they could send us. So that's why we want to create this automatically. Once uploaded, the file will be cleaned up, and then it can be used in the content management system. So this is how it looks like. So you basically log in, you have your different locations. You can just choose which location you want to go to. Then you see the 2D floor plan. You can choose a room. On the right side, you can choose the content. You can change the content, its orientation, how it looks like, its size. And when you want to go a little bit more deep into that, then you can fly into the room and get a 3D view, like we've seen before, of the building. And with this 3D view, you can see exactly where you place your content. You can change the height, the position, the orientation, and you can just move it basically by the inch. Here we have some 2D content, we have some 3D content in there, some videos that start playing. You can show basically anything that's possible to show in AR, you can show there as well. So, but even with the nicest TMS and the most accurate LiDAR maps, we still have to somehow localize the users and find out their positions. We do that by basically sending a query image from the phone to the server, and the server tries to find candidates that fit to the image and that help basically positioning the user inside the scene. So once a candidate is chosen, the algorithms are trying to find basically feature points inside these images and then calculate the position of the user compared to the image on the server to show the content in the right direction. So once the user has been located, which takes about usually 2 to 3 seconds, we are adding the 2D and 3D information to the scene at the correct spot where it will be displayed. So every user that looks at the 3D content will see the 3D content at exactly the same place. And this is the essence of our workflow, turning raw data into transformative AR experiences. In the background, aryve basically consists of 3 main parts. So first of all, we have the visual front-end app that can be a standalone app. It can be a white label application, but it can even run on just a website. So you can have web AR, you just scan, your customer just scans a QR code, the web AR application opens, and he can just locate himself inside the building without the need to download an application. The thing is, web AR is still quite limited, so that's why we use both technologies to basically enable, first of all, that customers can try it with a very low barrier of entry, and then download the main application from the App Store. The aryve core on the backend side can sit in the cloud or a local server. So when we have a museum, for example, that is really keen about data safety and they don't want to give their data out of the building, we can run a local server inside the building that runs Kubernetes and just use that one to calculate the positions of every visitor. And then we also have an easy-to-use content management system for customers to update the content with no development knowledge at all, as you have seen in the video before. As mentioned before, there's the 2 different possibilities, web AR and native AR app. Basically, we call the web AR application like the entry drug for the customer. So the barrier of entry is very low, so you can just provide them with a QR code, they can try it out, and if they like it, they can download the main application. And this will drive more users also to download your application, because it gives them a really additional value in the app, and not just advertisements or other things. So to reach the super fast localization time and save server resources, what is very important in big buildings where many people at the same time are using the technology, the number of images sent from the phone has to be as low as possible. So at the moment we send like 1 to 2 images, 1 image per second, up to 1 image every 2 seconds only. And that's enough for a good detection and a good positioning of the user. Since we have at the moment, let's continue. Sorry. So, since we have at the moment, in the last 3 years, we have improved our detection rates by quite a lot. And at the moment, we have a detection rate of really good positioning of more than 75% on average in a 3,200 square meter building or 35,000 square foot approximately. I don't know. Okay. So basically, the next step is we bring aryve to AR and MR headsets together with partners such as HTC, Magic Leap, and Qualcomm to really lift up the whole experiences even more. And glasses like these will be our personal navigation system, our window into the future, as they will transform how we experience the real world, literally and metaphorically. So what does it all mean with AR navigation? We turn lost into located and confusing corridors into a world of content. Our solution is here to stay, so you never have to ask for directions again. And remember, in the world of AR, not all who wander are lost. Some might just be enjoying the view. So, thank you. One more second. Thank you. Please visit us at our booth, 607. It's basically, I promise it's easy to find. You just go into the main hall and you go right, and then you will see our booth already. And we have some really amazing demos there. And we also have a secret demo you can ask for that we can show you. That's very amazing, I promise. And now I'm happy to answer your questions. We have a few more minutes, so thank you very much.
Thank you, Sascha. I think you guys have found the solution to finding my keys at the bottom of my purse, so I appreciate it.
You can try that.
I want to open up the floor very quickly. We have time for maybe 3 quick questions.
Yeah.
Yes.
Thank you. Hi. Wonderful demonstration here. I'm wondering if you've thought at all about the accessibility applications of this in terms of low vision and blind navigation. Because I know this is the type of functionality that a lot of folks in the academic community have been researching in order to understand. Curious if you've drawn on that research at all, or if you have any thoughts about a blind-friendly interface for the application.
Yeah, of course. I mean, this is a very big topic, and it's a very important topic as well, to make these applications also helpful for blind people. And you could do that also by giving voice navigations, for example. We are, of course, looking into that. At the moment, we just launched the technology that we've developed in-house. So if the technology is robust enough to really work 100% in any environment, anytime, then we can really use it also for blind navigation, and we will do so also in the near future.
Great question. Do we have any more questions?
Hi, so I am actually blind myself, and was kind of thinking as you were presenting that we've been using this tech for years in our own way. A lot of us have been doing indoor navigation with different wayfinding systems, and I'm curious if you have connections or have thought about collaborating, even just, I know I hear there's a plan in the future, but have y'all considered working with blind folks to talk about the things we've already learned from indoor navigation and the ways that we've made it more and more specific to the degree of like a foot or so even without the images so far? Has that been something that y'all have thought about?
Yeah, of course. I mean, when we develop in this direction, that the app is actually helpful, we have to, of course, get into conversation with blind people and their experiences with other navigation solutions. I know there's some visual solutions that can help also detecting objects, helping navigating basically through environments, and it's a very big topic, and it's also really, it requires quite a bit more work to get it right, that it really works well, and that you can really use it well. But I think this is one of the more important things also we have to consider in the next months and years developing this app.
Hello. Yeah, I was just wondering why you entirely rejected a sensor fusion approach. I mean, it's clear that camera is going to be the most accurate for close-up, but why not pay attention to any of the other sensor data coming into the phone?
We do, because for example, let's take the museum. Museum consists of like so many halls that are really big with really lots of stuff in there, but also really big empty spaces. That makes the whole 3D map we do with the LiDAR scan really big. So we have somehow to get a rough position of the user to basically limit the space in the LiDAR map we are looking for. And for that, of course, we can use Wi-Fi triangulation as well. We can use Bluetooth beacons. For example, the German Museum has at the moment, they have more than 3,000 beacons installed in the museum. They tried to use it for indoor navigation, but it didn't work. It worked, kind of, but it didn't work like as good as they wanted to. So that's why we can, of course, use that. I mean, when we get a rough positioning of about, let's say, 20 foot or something, or 30 foot even, that already helps a lot narrowing down the position of the user, and that makes the tracking and the positioning even faster.
One last question.
Hello. We have a mixed location with indoor and outdoor locations. How is this going to fit with your solution? Is this also a possibility, or is it harder to locate in the outdoor locations?
Outdoor has some other difficulties for localization. So like really like strongly changing lighting environments, for example, day and night, snowfall, rain, whatever, sunlight, direct sunlight with hard shadows and so on. Of course, outdoor is also really interesting, especially when you go for something like Disney World, for example, where like most of the park is outdoors. And then, of course, you can also combine that with outdoor and indoor navigation. At the moment, we are focusing mostly on indoor navigation because there's like more and more visual positioning systems already coming out, like the Niantic, for example, that really allows outdoor navigation based on like also rough positioning via GPS and then image detection as well. So that's why we are going more into the indoor navigation space because we got lots of requests that there's really no suitable solution at the moment for indoor navigation, especially when you want to show AR content on the way. That can be also like user generated or based on user interest content, and also like when you're in a shopping mall recommending products while you're going to a store, for example, like basically making an Amazon out of a shopping mall, more or less. So this is the idea.
Okay, everybody give it up really loud because I want to beat next door's applause for Sascha Kiener and his innovative approach
Thank
to
you.
indoor navigation. Thank you guys for stopping in for this.